These are the notes for 12.2. 12.2. A segment whose endpoints are on a circle is called a chord. So here's an example of a chord PQ. As you can see, both endpoints are on the circle. The diagram shows the related chord and arc. So PQ with a line over it is chord PQ, and PQ with the curved line over it is an arc. All right, here's some vocabulary. Congruent central angles have congruent chords. And a central angle, again, is when you have a circle, it's an angle that's at the center of your circle, central angle. So if two of these are congruent to each other, then their arcs here are congruent. Congruent chords have congruent arcs. So if I have a circle here and I have a chord from here to here, and it's equal to another chord somewhere, either on another circle or on the same circle, if these are equal, then the arcs are going to be equal also. And congruent arcs have congruent central angles. So on this one, congruent arcs. So if I'm talking about the arc from here to here, and it's congruent to the arc from here to here, that's going to be a bad example. Then this angle is going to equal, oops, it came out here, would equal this angle here. So the angles would be congruent. Chords equal distance from the center are congruent. And congruent chords are equal distance from the center. And we'll look at some examples here in a moment. In a circle, a diameter that is perpendicular to a chord bisects the chord and its arcs. In a circle, a diameter that bisects a chord is perpendicular to the chord. And in a circle, the perpendicular bisector of a chord contains the center. All right, so for example, in these examples, these two circles are equal to each other. Given that BC, arc BC is congruent to arc DF. So this right here is congruent to this right here. What can you conclude? You can say that the chords, so BC chord, so the straight line, is congruent to DF chord. And then also angle BOC is congruent to angle DPF. So the central angles are congruent. The central angles are congruent and the chords are congruent. And if instead you said the chords were congruent, then you could say the arcs. So BC arc is congruent to DF arc. And central angle BOC is congruent to central angle DPF. All right, find the radius of circle K. All right, so because this is perpendicular, that means it cuts it in half because it's a perpendicular bisector. So this side over here is 7 and this side is 7. Now I have a right triangle, So I can go my a squared plus b squared equals c squared. And remember, the hypotenuse is always opposite the right angle. So 7 squared plus 3 squared is going to equal x squared. So 49 plus 9 is going to equal x squared. So the square root of 58 is going to equal x. So you end up with 7.6 is equal to x. Next problem, find the radius of the circle below. 11 and 11, so that means this is a right angle then. So that means if this is 10.2 and this is 11, so a squared plus b squared equals c squared. Again, across from the hypotenuse in this case is still your unknown. So 11 squared plus 10.2 squared is equal to x squared. 121 plus 104.04 is equal to x squared. You add those two together, you're going to get 225.04 is equal to x squared. And then you take the square root of both of those, and you end up with around 15 is equal to x. So the radius is 15, right around 15.